Hello friends, welcome back to the bench. Our patient today is 2014 WRX STI, and this is pretty interesting case because unlike most ECMs that we work on, this one can be tested on the bench, so I can confirm the issue on the bench, and if we fix it, we can also confirm that it's fixed. Normally, I have to return the ECM to the client and let the client confirm whether the problem is gone. That's why normally I work on the issues that I know the procedure is gonna fix it, and if not, then I try to give like really fair prices, because it's maybe it's 50-50. On this one, what's wrong with it? We cannot communicate with it. So the customer states no response from ECU. I tried connecting through OBD2, kept getting error messages, and if you do cloning, I provide the second ECU, and the second ECU is in the box indeed. But before we get there, because what can possibly cause this? So first, the power issues, right? So we want to see 3.3 on this cap, 5 volts on this cap, and 12 volts on this cap, right? If we have all these, next, what can possibly cause it is IC 501. It's this one on this ECM. On older versions, the chip is located here. And that is the chip that one of its responsibilities is to provide the output stage for the MCU for the CAN bus communication. However, if this chip is okay, then if the MCU is faulty, MCU is communicating on the CAN, this is just the output stage, right? So even if this is okay, doesn't mean there's going to be CAN. So if the ECU is actually not communicating, one known issue could be the quartz, the oscillator. So we're going to check whether there's 10 megahertz on the oscillator. If all that checks out, the cloning, well, maybe let's not jump too far ahead. Let's hope this is gonna be a power issue, because if it's not, then we probably won't be able to clone this one, because for cloning to work, the MCU needs to be non-faulty, needs to be working. So usually when you want to clone, it's probably the the liquid damage on the board, or corrosion. Like, there's really got to be something really wrong with the ECM to do the cloning, because it's usually easier to figure out what's wrong and avoid cloning, because you gotta take off the chip of this size without bending any legs, right? Without damaging it, without overheating it, and you need to remove it from the ECM that you want to clone this one to, without disturbing all those components around it, right? So it's relatively risky procedure, depending on the tools you use, obviously. Okay, there's no signs of liquid damage, no signs of corrosion. The injectors are controlled by IC 651. So no IC 608 on this one. I still don't know how this ECM actually controls the ignition. because on well, actually, oh, we'll get there. It doesn't really matter. It doesn't bother us right now. Okay, so we need to check IC 501 and voltages and the crystal. So let's start with voltages. So let's get the pin out and let's get professional adapter. Copyright Black Horse Repairs. And this was probably 136. Let's see. So we want control module power supply 136 pin 1. So it's this one. The ground will be probably on pin number 4, but grounds are at the very end. Body ground 136 pin 4. Yeah. So I know this ECM. Actually, so this is 2014, right? Previously we worked on 2017, and the only difference that I can see is that IC 753 and 754 are missing. And that's the only difference visually that I see between 2014 and 2017 version. Other than that, everything seems to be the same. Layout and everything. So it's the same board, it's got just different connections. Now, can high and low, we actually don't need that yet. First, let's confirm that we don't have shorts and that we have all the voltages. So let's set the power supply to 12 volts. Let's actually limit the current to 1 amp. We're not going to need more. The ECM should take 2 watts roughly when you just connect the power to it, right? It is controlled by the voltage is dropped by TO2 and TO1. These are linear regulators. This is 5 volts and this is 3.3, which means this one will be heating up, so that is normal when you see it on the thermal camera, that this one is heating up, completely normal. This one will be less heating up because it's higher voltage, right, the Ohm's law. And this chip will also be heating up. We also want to see a spot over here in the MCU that will confirm that it's powered up. And these 2 chips will also be slightly heating up. But we don't want to see more than 2.5 watt of power draw. And let's find the ignition switch. Ignition control, ignition switch. 13630. 30 is this one, right next to CAN. It's this guy. Okay. So we have power and ignition switch connected. Now ignition switch will cause the ECM to draw slightly more, not much more, like 0.2 watt more when you connect it, something like that. And that's true for pretty much all the ECMs that I've worked on so far, be it from 2000, well, anywhere from around 2008, 2006 maybe, further. For some reason my scope is, you see those, oh yeah, you see that thing? What is going on? Well, let's hope it's gonna subside. Okay, now let's grab our power. Now if you connect it in reverse, it will just, the whole current will be just drawn by the diode. somewhere here there's a diode somewhere here. So if you connect it in reverse, don't worry, you're not gonna break it. But make sure you have OCP enabled, and that way it'll only be slight pulse, and the power supply will turn off. Now, okay, let's review. 1 and 4. 1 is power. Control module 1 is power plus. Okay. So let's put this over there for now, and let's get the multimeter. Set it to volt finder, and let's find some volts. I could actually, I could just check the resistance right now. That will tell us if there is a short or not. But it doesn't matter because we have OCP on the power supply, so it's fine. Okay, let's turn on, and we're grabbing 2.3 watts. That is correct. Now let's catch the ground over here on this cap, and we want to see 3.3 over here. We have 3.269. That is fine because we are using linear regulator, so this is not typically stabilized voltage, no feedback on it, so this is normal. 5 volts over here, 4.9998, also fine, and that means we're gonna have 12 volts over here. We don't even need to check, because if there was no 12 volts here, we would not have the rest of the volts, the rest of the voltages. And so we have the voltages, so that's fine. So now let's confirm, not that we don't trust the customer, but let's confirm that indeed we cannot communicate with it. So let's turn it off, and let's connect the CAN bus. So my yellow one is high, my brown one is low, and CAN bus. CAN bus is on B136, 17 and 28. High is on 17. High is on 17. This is high. And low is on 28, right below it. Typical. It's usually arranged this way. From there, let's grab the tool. Let's turn it on. Oh, it was turned on. I didn't turn it off. Oh, right, because I was updating. Network, right, blah, blah, blah. Okay, I didn't finish update. I still have 11 packages to update, which is fine. I usually work on rather old cars, so I don't necessarily need all those updates. Now, oh, and I didn't check one more thing, because I didn't check the ignition. Let's check again. So 2.3, and if we connect the ignition to power source, we have 2.6. 2.3, 2.6. Yeah. So ignition is fine. ignition switch at least. We don't know about the ignition, right? That is not something that we can check. Okay, let's connect it. Turn it on, but now it might actually OCP on us. No, yep, it OCP'd on us. The reason is because X-Tool wants to start charging. So we need to increase the maximum allowed current. 2 amps should be okay. Yes, 1.2, because this is charging now. This is normal. But it has nothing to do with the ECM. Even if the ECM is completely dead, this will still charge. Now, let's do diagnostic and go to OBD. And it would have, yeah, it didn't find anything. Let's do auto scan just in case, but looks like this one is not responding. Indeed. Yeah, it would have found it by now. So we know the CAN is not working. There is no communication. So we have voltages. So now let's check the voltage on the CAN. If it's fluctuating. It's 2.5 and it's not fluctuating at all. And CAN low is also 2.5. So both rails are at the same potential. So that's a dead CAN. I mean by dead, I mean it's not communicating, right? VIN code is not recognized. Please input it manually. Well, I'm not going to input it manually because we can't communicate, so it makes no difference. So if there's 2.5, right, if there was 0 on both cans, high and low, that would point to IC501 being faulty. But if there is voltage, that's probably not our issue. This is probably the MCU not actually responding, not doing what it's supposed to be doing. So, I mean, we can still replace the chip and, you know, in the hopes that maybe, right? But I would say probably not. So in this case, let's check if we have a clock signal over here. Let's connect the scope. Let's grab this. This is not going to be reliable measurement, but all we want to confirm is whether whether there is frequency on that pin on the quartz. And we're gonna tap it over here, and we have beautiful 10 megahertz. I don't know if you can see that on the scope over there, probably not, but yeah, it looks like sine wave because it's high frequency, so that's normal. But we have 10 megahertz on the quartz, so the MCU is receiving clock signal. It's receiving its power. It's 3.3 volts. The output stage is, yeah, it's warm. That's normal. This is warm. That's normal. Let's see under a thermal camera if there's anything abnormal. But if there was anything abnormal, we would see the higher current draw. No, is it the cable here that's causing this? I think I need to think of getting a new microscope, because this one is crapping out on me. Oh, phone is starting, of course. And yep, this is all good. Okay, MCU is powered. It's heating up to 38 degrees. That is good. So MCU receives power. I can't really show it to you reliably. Maybe like this. So we're pointing at MCU over here. This one. It is lighting up. Obviously our regulators. So this one is the hottest one. This guy. Because it does 3.3. So the most voltage drop on it. And this one's 5 volts, so it's less that. And our IC501 is warm. 45 degrees, that's normal. And these two chips, 35 and 35. Yeah. So if one of these was abnormally high, abnormally, hot, meaning it would be hotter than the other chips. That points to like there might be something wrong with that one. But I don't have the replacement for these, and I don't know what they're responsible for. So even if I found that, I wouldn't really know what to do with them. But this one seems to have a fried MCU. Yeah. So, transplant. Can we do a transplant? Well, as I said, to do the transplant, you need a working MCU, right? So we basically just desolder this one and put it on another board, and that's the whole brain, right? That's where your VIN is and everything. Or at least that's the assumption at this point. I do have 2 of them over there that I will clone, and that will confirm it, but so far everything points to that. Basically, I eliminated almost all the other chips as far as being responsible for holding that data, and the only one that could potentially hold that data so far is the big MCU. Now, if we wanted to try, let's see the second one. But before we do the second one, let's put this one back in the box so we don't mix them up, because they're labeled. This is 2009. This isn't gonna work. 2014 and above are the same. Well, the same. As we can see that the difference over here between 14 and 17 is those 2 chips are missing on this one. So probably we wouldn't want to transplant this from 2017 to 2014. and vice versa. Probably. Maybe one day we'll try. But before 2014, the layout of the board is different, and it's a different ECM. That's why we don't need to put it back in the box, because you will see it immediately, the difference between them. Instead of using linear regulators on these ones, because they take more power, we have two coils, big caps over here, and transistors. These are not linear regulators, these are transistors. So that's our power supply. This is where we get 3.3 and 5 volts, right? And on this one, these two give you 5 volts and 3.3. The other difference is, and let's see that under the scope, this is IC 602. It's responsible for ignition. By ignition, I mean the actual ignition on the engine, not the ignition switch or the ignition relay, the actual spark on the engine. This is what controls it. So see, this chip is missing from the newer boards. So I still don't know how the ignition is actually controlled on these ones. I will find out eventually, but for now it's a mystery. Also, and this is how you can tell the difference between the Outback or Legacy and WRX. IC 703 and 704 will be present on WRX STI, while on Outback there will be missing from factory, right? The layout is the same, so this is Outback. You see let's actually do the big camera. So this is WRX, and this is Outback, right? And actually, hang on, let me show you the one that is not stripped from parts. Either Outback or Legacy, it doesn't really matter. Or Legacy Outback. So the same power supply. Like this, same power supply. Those two chips missing, right? Our ignition control over here, right? And on WRXs, those two chips are actually present. What do they do? I have no idea. But another thing, we have the ignition control on it. The power supply with two coils, right? And our 501 is on the left here, right? On 2014 and up, our 501 is here. There's no ignition control chip, and those two chips, the 703 and 704, are on this side over here. So for that reason, there's no way to do the transplant here. I mean, I wouldn't expect the transplant to work. I've never tried, but they're different enough that I wouldn't expect the engineers to just kind of, you know, make it in the way that it's fully, you know, compatible. Like the outputs of the MCU always are the same, and regardless of the board layout, it's always going to be the same. I wouldn't expect it, especially since we have a different chip over here. I don't know how the ignition is controlled on these, and I know it's probably not the, because I was thinking that either IC 703 or 704 are responsible, right? Because on these, right, we have IC 602 for ignition, but these are missing, right? And on this one, We don't have that chip, but we have those two. So that would work if it wasn't for this one. This one has both these two chips and the ignition chip, right? So our ignition must be controlled by something else. What is that? I have no idea. But let's put the legacy back. And I'm afraid that this is gonna be just plain old no fix. Because, and I was thinking, okay, if this MCU is fried, what we can do is I can ship this off to Pennsylvania to the practical mechanic, and he can program this to your VIN. But the reason this will not work is 2008, 9, and possibly 10, I think 10 too, they have different layouts, different connections. So here we connect to B136, 1 and 4 power, right? And CAN is on 1728. On this one, this is 2008 legacy, but it's going to have the same pinout. The power is pin number 7 on B134, so on this one instead of this one. And the ground is on number 5, and the CAN is, I don't remember what the CAN was on, it should be at the end, yeah. 136, 27 and 35. 27 and 35. It's on the other side of the connector. So even though the connectors are the same and the cables will fit, the outputs are different. So it will just not work, and probably if you connect it to your car, it will probably fry it up. That would be my guess. Definitely it won't work. Where did you get this one though? Because they're both WRXs, STI, but I don't see in the ticket, I don't see any mention what the year the actual car is. I'm gonna have to call the client, because if you replace these, then no wonder this one doesn't work. If your car came with this and you have 2009 WRX, but you put the 2014 ECM in it, then that would explain why this ECM is dead. I mean, it could explain why this one is dead, because the pinout is different. So maybe we applied voltage where the voltage doesn't go, and we just sent 12 volts to the MCU. Then I would kind of expect it to just kind of start, to just short out. On the other hand, there's plenty of resistors around, so maybe, maybe I'm wrong. But let's see the CAN. Let's see the CAN. 27. So let's see what's on 17 and 28 on legacy. B136, 17. Let's see the 17. This is 17, B136. Okay, drain valve. Yeah. Yeah, so we just send, okay, so that would make sense. So we just sent 14 volts to the CAN This is 17 to can high. Let's see can low. This is 28. 28 on 136. Maybe 135, 28. Pressure control solenoid, again 14 volts. So we just send, so if you connected this instead of this one, then you essentially send 14 volts to both rails. Now is that not good? I don't know, I never tried that. It never occurred to me to try that. But I would expect that it would actually it would make sense that we damaged the output of the MCU, because IC501 is likely an H bridge. So if you connect the load, yeah, it could fry up the outputs of the MCU. So MCU is working, MCU wants to work, but the outputs of the MCU are fried. That's why we have stable 2.5. Maybe. Well, yeah, because MCU is supplied with 3.3, right? Yeah, we probably shouldn't have more than 5 volts, because it's hanging in the middle, right? Because that's how a can works. It just kind of fluctuates on both. You know, a can is a very unique bus. It's unlike anything else that we use in electronics, like SPI, I2C, what have you. And can is really different. But the way I understand it, it just fluctuates. So now it's hanging. Both rails are hanging in the middle, right? And they can either go high or low, and so they can go to 5 volts differential or 2.5 volts difference, 0, negative, right? So that's how it communicates. So now it's hanging in the middle, which would you know, kind of suggest that it's not being driven, right? It kind of behaves the same way as you just remove the MCU from the board, right? And measure that it's going to show you 2.5. It's just waiting to be controlled, but nothing is controlling it. So the output stage is just keeping them at half of the supply voltage. Yeah, I don't think you should connect 12 to 14 volts to CAN bus. So if that was the case, if your car came with this and you put this one on, then this one is fried, definitely. But that is if your car is 2009 and not 2014. Well, I guess we need to confirm that before we do anything else with this. That is such a weird case. But you see, it's very important to give me as much information as you can for this particular case, right? I don't even know what age your car is. That would tell me something. Yeah, okay, well, we're not gonna fix anything today. Well, or maybe we will. Oops, what am I doing? Or maybe we will if I get in touch with the client. But it is Memorial Weekend. Nobody's working, right? Only maniacs work on Sundays and Memorial Days. It is too bad, though. But yeah, there's pretty much nothing else we can do here. So at worst, the customer just pays the bench fee for testing, and I guess we'll go from there. Such a weird case. But if we do find out that the car is 2009, then we know what happens when you put 2014 in it. And I think the confusion came from 2014, 15, 16, 17, and I don't know, maybe higher too. They are the same. They are replaceable, or at least to certain. At least they have the same pinout, right? But anything earlier is gonna have different pinout, different board, all of that, because it's a different generation. Now, curiously, 2009 and 2010, I do not have the pinouts for the WRX STIs. For some reason, I don't have them. I don't know where to get them from. I have pinout for pretty much all of them, but except these two. Or actually, I don't have like some really old ones and like really new ones. But other than that, I have all of them except 2009 and 2010. So if you do have the pinout for these, definitely hit me up. I'll buy it. But for now, I guess we're done with this one. We're gonna call the customer and find out what he wants to do with this. In any case, thank you guys very much for watching, and I shall see you in the next one.